What's going on? Got another video here for you. This one ought to be a good one. We're going to do integrals by partial fractions. So let's get started. We got quite a bit to do. All right, so we're going to basically what we're going to do is we've got four different scenarios. We've got non-repeated linear factors, repeated linear factors, non-repeated quadratic factors, and repeated quadratic factors. And so the first one we're going to look at is non-repeated linear factors. We'll work some examples of that, then we'll go to the next one, work some examples, and so on. So let's see what we've got here. So non-repeated linear factors. So corresponding to each linear factor, ax plus b, occurring once in the denominator, there will be a partial fraction of the form, this right here, a over ax plus b, where capital A is a constant to be determined. We'll have to figure out what a is. All right. So let's look at an example. So here we want to integrate 7 minus x over x squared plus x minus 2. So the first thing we want to do is we look at this denominator here and we notice this thing can be factored. So if we look at that, we can see x squared plus x minus 2 can be factored into x plus 2 times x minus 1. So we can take the 7 minus x over x squared plus x minus 2 and write it as this. Okay? And look, I know I'm erasing this and writing x minus 1 first and then the x plus 2. It doesn't matter which one you write first. Makes no difference. Okay? All right, so now what does it say? So for each linear factor, we're going to have a over that linear factor. And so this is going to be a over x minus 1, see, for this linear factor, plus, and then we have another linear factor, it's non-repeating, these are two different ones, over x plus 2. All right, and so that's this part right here. So for each different one, we have a over that, and then we had a second one, so we had to put plus b over the other one. All right, and so that's all this means. See, the non-repeated linear factors. Now later on we're going to have one where, like this one, will have like a squared or a cubed on it. Okay, and that's a little different there. All right, so what do we do now? Well, we've got to figure out what a and b are. So what we do is we multiply by the common denominator. Okay, multiply everything by the common denominator. So that knocks all this out. So we've got 7 minus x equals, and see here the x minus 1's cancel, so we're left with a times x plus 2 plus, and then the x plus 2's cancel, we're left with b times x minus 1. All right, now all we want to do is figure out what a and b are. So how do we do that? All right, so what I'm going to do is I'm going to let x equal 1. Okay, so where did that come from? Did I just pulled that out of the blue? No, I chose, and you know, you can choose x to be whatever you want. That doesn't matter. Okay, but do something that benefits you. So by choosing x equal 1, notice when I plug it into here to the x minus 1, it makes this whole term here go to 0, and I'm just left with this term here. See, 1 plus 2 is 3. I'm left with 3a equals, when I plug 1 into here, that's 6. So when I plug the 1 in, I'm left with 3a equals 6. So now I'm able to solve for a. Okay, that's why I chose the 1. And so That's going to give us 7 minus 1 equals a times 1 plus 2. Now, I'm plugging all this in and showing the work on this problem. As we go through the video, I'm not going to write this step. Okay, I'll just say, well, I'm plugging it into here, and this would be the answer. But I'm going to show all the work right now. And then when I plug the 1 into here, 1 minus 1 is 0. 0 times b is 0. So this leaves me with 6 equals 3a. So a is equal to 2. And then I'm going to let x equal. Can you guess what I'm going to let it equal? That's right, negative 2. Because when I let x equal negative 2, it's going to make this term go to 0, and I'll be able to solve for b. So that's going to give me 7 minus negative 2 equals b times negative 2 minus 1. And so this is going to be, what is that? 9 equals negative 3b. And so b is equal to negative 3. All right, so now I've got A and I've got B. So now I can come up here and rewrite my problem. 7 minus x over x squared plus x minus 2. X squared plus x minus 2 equal I left off the dx. And that is equal to, now remember, this right here is equal to this, okay? And a is 2. So that's going to be 2 over x minus 1 minus, because it's a minus 3. So, I mean, I could put plus negative 3, but I'm just going to go ahead and put minus 3 over the x plus 2. And that is dx. All right. So now what we're going to do is we're going to take 2 times the integral of 1 over x minus 1 dx minus 3 times the integral 1 over x plus 2 dx. So what I did there is I split them up into 2 different integrals, and the numbers here, the 2 and the 3, I pulled those outside the integral. Now, from now on, when I go from this step to this step, I'm not going to write it all in one and then split it up. I'm just going to go ahead and split them up. Okay? All right. So now we've got 2 times. Now, what's the antiderivative of this? Well, let's just come over here to the side and do this one. And I'm not gonna do this for every one that's like this, but I will for this one. But if we have one, let me do it in a different color. So if we have the integral of 1 over x minus 1 dx, notice if I let u equal x minus 1, then du is equal to dx. So I can replace the x minus 1 with u, and the 1 dx, see this 1 dx, I can replace that with du. And this is what? Natural log absolute value of u plus c, which is natural log absolute value. And then I plug the x minus 1 back in for u, and that would be the antiderivative of this, which would be natural log x minus 1. Okay, and then minus 3 times. Now look at this one. This is the same thing. If I let u equal x plus 2, then du is dx. So you can look at it like that, or you can look at it like this. What's the derivative of the denominator? Well, the derivative of the denominator is 1. And remember, if the derivative of the denominator is in the numerator, then it's natural log of that denominator. And so this would be your answer. Okay? So I showed quite a few steps on this first example, and as we go through, I'm not going to show all the steps like I did in this one. For instance, I'm not going to show plugging this in like I did here. We'll just plug it in and do that in our head. Now, keep in mind, if you need to plug it in like this, that's fine. All right, let's look at the second example. And I know this might seem like I jumped to this. I don't know what happened, but right when I was on that first problem, the recording stopped. So I just saved it and I'm going to stitch them together. All right. So let's look at this one. So this is the same thing. Do you see how we have non-repeating linear factors? See, all of them are different. Okay. And so now I've got 6x squared minus 14x minus 11 over x plus 1 times x minus 2 times 2x plus 1. And that is equal to, so that's going to give me a over x plus 1 plus b over x minus 2 plus c over 2x plus 1. All right. So, however many different factors you have, you just keep going. Okay. So now we need to multiply everything by the common denominator, which is x plus 1 times x minus 2 times 2x plus 1. And so that's going to give us 6x squared minus 14x minus 11 equals a times, okay, so the x plus 1's cancel, and I'm left with x minus 2 times 2x plus 1. So that's going to be x minus 2 times 2x plus 1 plus b times, and the x minus 2's cancel, so I'm left with x plus 1 times 2x plus 1. And then plus c times, and then the 2x plus 1 cancels. I'm left with x plus 1 times x minus 2. All right. So now, well, let's start out. Let's let x equal 2. So why did I choose x equal 2? Well, if I plug 2 into here, this entire thing's going to be knocked out, going to go to 0. And this one's going to be knocked out and go to 0. And I'm left with just this term, and I can solve for b. Okay. All right. Now, let's plug the 2 into here. And I'm going to have to punch that into my calculator. So I'm plugging 2 in for x right here. So that's going to be 24 minus, what is that, 28 minus 11, that's negative 15. Okay, so that's going to give me negative 15 equals, and then when I plug 2 into here, that's going to be 2 plus 1 is 3, and that's going to be 5 when I plug the 2 in, so 3 times 5 is 15, so that's 15a. And so a is equal to negative 1. Nah, I'm such a dummy. That's b. B is negative. I don't know why I wrote down a. All right, so that's for x equal 2. All right, so now let's look at x equal negative 1/2. All right, so for x equal negative 1/2, let's plug the negative 1/2 into here. All right, so when I plug the negative 1/2 into this one, I get negative 5/2. All right, this term and this term, the a's and the b's, they go away. And then when I plug the 1/2 into here and here, I get equals negative 5/4 times c. And so then I multiply everything by negative 4/5, and you can see the 5's cancel, and then the 2 and the 4 cancel, and the negative is positive, so I get c equals 2. And then I'm going to let x equal negative 1. So when I plug the negative 1 in, that's going to give me 6 plus 14 minus 11. That's going to be 9 equals, and let's see, this term and this term's going to 0, and that's going to be negative 3 times negative 1 times negative 1 is positive 3, so that's 3a, and so I get a equals 3. All right. So, yeah, I admit it's quite a bit of work doing these things. But, it is what it is. And so now I've got this integral here, and I'm not going to rewrite this integral, but this integral is equal to the integral of this. Okay, so I've got to plug the a, the b, and the c in for each of those. And remember what I told you, I'm going to go ahead and write them split up. And so my integral is going to be the integral, and a is 3, and I'm going to pull the 3 out, and that's going to be 1 over x plus 1 dx. And then b is negative 1, so minus the integral 1 over x minus 2 dx. See, it's plus negative 1, but I'm going to pull the negative sign out. All right. And then plus, and then c is 2. So I can pull the 2 out. I'll explain that when we work the problem, but I'm going to leave it in there, and I'll show you why. Okay. All right. So let's look at this. So we've got 3 times, and then this is what? This is just the natural log of x plus 1 minus, and then this is the natural log of x minus 2 plus, okay? Now, let me explain this. Let's suppose I pulled the 2 out, okay, and put this as 1. Well, remember I told you in the first problem, if you can take the derivative of the denominator and that's in the numerator, then it's natural log. Well, look at this. If I take the derivative of this, that's 2. Well, I've got the 2 out here. I've got a 1 here. Okay. So what I'm going to do is I'm going to take that 2 and I'm going to bring that 2 in here. So now the derivative of the denominator is 2, which is in the numerator. So that's just natural log absolute value 2x plus 1 plus c. And, that part right there, integrating that, or integrating each of those, that's something you should know how to do already. Okay, this is just basic U substitution. Okay, you learned that earlier. All right, so that's that problem. All right, now let's look at the next example. Okay, now this is one thing I haven't said yet because it hasn't come up, but when you're doing partial fractions, the largest exponent in the denominator has to be larger than the largest exponent in the numerator. Okay, so for instance, this problem that we just worked, see how the largest exponent in the numerator is 2, and the largest exponent in the denominator, if we multiplied all of these out, would be x cubed. That's what you've got to have. Okay, but here, see how the largest exponent in the numerator is 4 and the largest in the denominator is 3? You can't do partial fractions like that. Okay, so we've got to do something. We've got to do long division. Okay, so I've got to do long division here. And that's going to be 2x to the 4th minus x cubed minus 9x squared plus x minus 12. All right, so I'm going to go through this kind of quick. Long division, you should be able to pick up on it or understand how to do it. If not, after this, just go to my channel, search for long division polynomials, and I have a video explaining how to do it. Okay. All right, so the way we do long division, we look at the x cubed. What do you need to multiply to this to get this first term? Well, that would be what? 2x. And so then I take the 2x and multiply it to this. So that's going to be 2x to the fourth minus 2x cubed minus 12x squared. And that's it. All right. So now what do we do? Well, now we have to subtract, but what we're going to do is we're going to change the sign of each term and add. That's the same thing as subtracting. So that goes out. This is going to be x cubed. And then we've got, let's see, plus 3x squared. And then we bring down our next term, plus x. All right, now what do I multiply to this to get this? Well, that's a 1. And so that's going to be x cubed minus x squared minus 6x. Change the sign of each term and add. So that's 4x squared plus 7x, and then bring down the next term, minus 12. All right. And so the answer to this is this thing right here, this 2x to the fourth minus x cubed minus 9x squared plus x minus 12 over x cubed minus x squared minus 6x is equal to the quotient, which is 2x plus 1, plus the remainder, 4x squared plus 7x minus 12 over the divisor, x cubed minus x squared minus 6x. Okay? All right. So that's doing the long division. Okay? So I'm going to erase this, so we'll have more room. All right, now, remember, what we have to do is we have to integrate this thing. Well, this thing is this. Well, I already know how to integrate 2x and 1. I don't know how to integrate this. So I'm going to have to use partial fractions on the remainder. Okay? So if we take the x cubed minus x squared minus 6x and factor it, that's x times x squared minus x minus 6, which is x times x plus 2 times x minus 3. So I've got 4x squared plus 7x minus 12 over x times x plus 2 times x minus 3. All right. So now I have a over x plus b over x plus 2 plus c over x minus 3. Okay. I mean, now it's just like the first two problems that we worked. Okay, it's the same thing. All right. So now we're going to multiply everything through by the common denominator. And so that's going to leave me with 4x squared plus 7x minus 12 equals, and that's going to be a times x plus 2 times x minus 3 plus bx times x minus 3 plus cx times x plus 2. And then what are we going to let x equal? We're going to let x equal 0. Okay, that knocks out this term and this term, and I can solve for a. So that's going to give me negative 12 equals, let's see, negative 6a. And so I get a equals 2. negative, yep, a equals 2. All right, and then I'm going to let x equal negative 2. So that is going to give me, let's see, so that's going to give me negative 10 equals 10b. So b is equal to negative 1. And then I'm going to let x equal 3. Okay. And just to save some time, that's going to give me c equals 3. Okay. You just plug the 3 in for x. And then once you solve for c, you'll get 3. Okay. You should be able to do that. Okay. It's going to be a long video anyway, so. All right, so now remember, it's the integral of this, so that's going to equal the integral of 2x plus 1 dx. Okay, we're integrating this, which is all of this. So it's the 2x plus 1. I can integrate that easy. And then, so I've got the integral of this. Now the integral of this, which I did I broke up into this. So that's going to be plus, and remember what I told you, I'm going to pull these numbers out. So that's 2 times the integral 1 over x dx minus, so that's a minus 1, so I'm bringing the minus 1 out, 1 over x plus 2 dx plus, and then c is 3 times the integral 1 over x minus 3 dx. And so this is equal to x squared plus x, that's the integral of this, and then this one plus 2 natural log absolute value x minus natural log absolute value x plus 2 plus 3 natural log absolute value x minus 3 plus c. And there's your answer. All right. So that was quite a bit of work there. Okay. All right. Well, let's see what we got now. Okay. Repeated linear factors. All right, so corresponding to each linear factor ax plus b that occurs n times in the denominator, there will be n partial fractions. And that's the a1 over ax plus b plus a2 over ax plus b squared all the way to a sub n over ax plus b to the n. And the a1, a2 all the way to an, we have to figure out what those constants are, just like we did earlier. So let's take a look. All right. So this one. All right. So let's write it out. So we got 1 over x times x plus 3 squared. All right. So we got the single linear factor here, 1 over x. A over x plus. Now notice here, I've got 2 of them. I got x plus 3. I've got 2 factors of it. So what does this say? I got to put a constant over that factor to the first power, and then a constant over it to the second power. And so that's going to be plus b over x plus 3 plus c over x plus 3 squared. All right. And that's all it is. If this was a 4th power, then you would have d over x plus 3 cubed plus e over x plus 3 to the 4th. I mean, that's all you're doing. Okay, you just got to do one for each factor, and notice, whatever power it's raised to, you just keep going, and that power just keeps increasing until you get to whatever it was, raised to the nth power. All right, so now we need to multiply by the common denominator, which is x times x plus 3 squared. And so that's going to leave me with 1 equals a times x plus 3 squared plus bx times x plus 3 plus c times x. All right, so now let's see what we do here to solve for this? Well, I can just start out by letting x equal -3. That's going to knock out this term and this term. So that's going to give me 1 equals -3 times c. And so that gives me c is -1/3. And then I can do x equals 0. That's going to knock this one out and this one out. And that'll leave me with 1 equals 9a. Because that'll be 3 squared is 9. And so a is equal to 1/9. All right. Now, what do we do? There's nothing else we can let x equal so that we can knock out a and c and solve for b. Do you see that? So what about I just let x equal 1? How about that? I mean, we already know what a and c are. And so that's going to leave us with 1 equals. So we're plugging 1 in for x, and we know a is 1/9. So that's 1/9 times 1 plus 3 squared plus b times 1 plus 3 plus c, which is -1/3. So that's -1/3 times 1. And when we do all this arithmetic and all that good stuff, we end up with b equals -1/9. All right. So, I mean, you know, if that happens where you knock it out to get c, you knock it out to get a, but then you can't knock out anything to get b, well, just pick a number for x. Okay? And plug in what you got for a and, a and c, and then we can solve. All right, so now here we have it. We're doing the integral of this, which is these added together with the a, b, and c plugged in. So this is going to be the integral. Now, and I'm going to pull the numbers out. So a is 1/9, so that's 1/9 times the integral 1 over x dx minus 1/9 times the integral 1 over x plus 3 dx minus 1/3 times the integral 1 over x plus 3 squared dx. All right, so this is easy here. This is 1/9 times natural log absolute value of x minus 1/9 times natural log absolute value x plus 3 minus, I guess it's going to be minus, I don't know, we'll have to see when we integrate it. Now, this one's a little different. So let's come over to the side and show all the work of how we do it. So I've got the integral of 1 over x plus 3 squared dx. So here I'm going to let u equal x plus 3, so du is dx. So we can make our substitution. So that's going to be the integral. Now you see the 1 dx, I'm going to replace that with du. And then the x plus 3, I'm going to replace that with u. And so that's the integral u to the -2 du. And so how do we integrate? We add 1 to the exponent, multiply by the reciprocal of our new exponent, plus c. And so this is equal to -1 over u plus c, which is -1 over x plus 3 plus c. And so that's what that is. So we've got the negative and the negative. That's going to make a positive. And we've got the 1/3. And this is times 1 over x plus 3 plus c. And, if you want to, you can rewrite this 1/9 natural log absolute value of x minus 1/9 natural log absolute value x plus 3 plus 1 over, and you can write it as 3 times x plus 3 plus c, or you can put 3x plus 9, whatever you want to do, okay? As far as I'm concerned, you're in my class, you get to this point, I'm happy, okay? All right. So let's go to the next one. Ooh, look at this one. This one doesn't look fun at all, does it? Let's see what we got here. All right. So we've got 3x cubed plus 15x squared plus 21x plus 15 over x minus 1 times x plus 2 cubed. All right, so that's a over x minus 1 plus b over x plus 2 plus c over x plus 2 squared plus d over x plus 2 cubed. And we are going to multiply everything through by the common denominator, which is x minus 1 times x plus 2 cubed. And we are left with 3x cubed plus 15x squared plus 21x plus 15 equals a times x plus 2 cubed plus b x times x plus 2 squared plus cx times x plus 2 plus dx. All right, so I think I got all that written down right. I think we're good there. All right, so now here comes the fun part. This is really fun. This is a nasty one here. All right, so you can see I can let x equal 0. And so that'll knock out all those terms, and I'm able to solve for a. Okay. And so with that said, let's see. What do I get? My goodness, look what I did. Boy, did I messed that up, didn't I? Disregard what I just wrote down. So this is going to be, don't ask me why I was sitting there thinking it was a over x. It's a over x minus 1. So I multiply by this. This is going to leave me with a times x plus 2 cubed plus b times x minus 1 times x plus 2 squared plus c times x minus 1 times x plus 2 plus d times x minus 1. All right, so that looks a little better, I believe. So we're going to let x equal 1, and that's going to knock out all these terms. And when I plug 1 into here, that's going to give me 54 equals, and that's going to be 27a. So that gives me a is equal to 2. And then I can let x equal negative 2. And that's going to give me 9 equals negative 3d. Okay, I'm just plugging the negative 2 in. Okay, see, it's knocking out all these, and that'll be negative 3. And when I plug the negative 2 into here, I get 9. So that's going to be d equals negative 3. All right, so now here's where we have a problem. So we've got to figure out what b and c are. Now, I'm not gonna do like I did last time. So like last time, what did I do? I just let x equal a number, some other number, like, maybe 0. We could let x equal 0. But then I still have b and c are unknown. So what we're going to do here is we've got to multiply all this out. Okay? So let's look at this. See the x plus 2 cubed? Okay? So let's just come here, right here, I guess. X plus 2 cubed is equal to x plus 2 times x plus 2 times x plus 2. And when I FOIL these two, I get x squared plus 4x plus 4 times x plus 2. And then I got to multiply these two. So that's x cubed plus 4x squared plus 4x plus 2x squared plus 8x plus 8. And so that's x cubed plus 6x squared. Is that right? Yeah. Plus 12x plus 8. Okay. So what that's given me is that 3x cubed plus 15x squared plus 21x plus 15 is equal to, all right, so it's a times this. So I'm going to distribute the a to each of the, well, let's just write it all out. X cubed plus 6x squared plus 12x plus 8. Okay, so that's that. And then I have to do the same thing with this. So when I FOIL this out, that's x squared plus 4x plus 4 times the x minus 1. Okay, and so that's going to be x cubed plus 4x plus 4x squared plus 4x minus x squared minus 4x minus 4. And so that's x cubed minus, was that 3x squared? And it looks like the 4x's go out, minus 4. All right, so that's going to be plus b times, and that's going to be x cubed minus 3x squared minus 4. All right. And then we've got to do the same thing here. So that's going to be plus c times, and when I FOIL that out, that's going to be x squared plus x minus 2, and then plus d times x minus 1. All right. And I hope I haven't made a stupid mistake somewhere. If I have, then you know I did. Okay, this all gets, it's a lot. Okay, so now I've got 3x cubed plus 15x squared plus 21x plus 15 equals, now I've got to distribute each of those. So that's going to be ax cubed plus 6ax squared plus 12ax plus 8a plus bx cubed minus 3bx squared minus 4b plus cx squared plus cx minus 2c plus dx minus d. All right, and then we want to combine the like terms together. So I get 3x cubed plus 15x squared plus 21x plus 15 equals. Now, you see how I have common terms with the x cubed? Well, that's a plus b times x cubed. Okay. Now, I'll know if I made a mistake somewhere, and if I did, I'll let you know. I probably won't go back and fix it, but hopefully you get the idea of what you got to do. Okay, if I made a mistake, it's just because I multiplied or added something wrong. Okay, the problem that I'm working out of the book, the part I'm writing down, it's got that part written down. It just doesn't have all this other stuff, so I'll be able to check and see if I got what they got in the book. Hopefully I didn't make a stupid, careless mistake. So that's the x cubed. Now let's look at the x squared. You see the x squared term here? Look, see here, where's another x squared? There and there. So we can write this as plus 6a minus 3b plus c times x squared. See, I factored all that out. Well, all right, and I can check real quick. 6a, oh, let's see. They have a plus 3b, and I have a minus. So I'm going to pause the video and see if I can see where I messed that up. Okay, so I found it. 4x squared minus x squared is plus 3x squared. So I screwed that up. So this right here, change that to a plus, and then that would be a plus right here. And so that would make it a plus right there. All right. I don't know why I put minus, but you know, I didn't want to do that, but I'm glad I did. Just shows you, be careful. Watch your signs, okay? You might have caught it earlier, but yeah, that's supposed to be a plus. All right. All right, so we're good there. And now let's look at the common factors of x. So that's here, here, and here. So let's see if I screwed something up there. So plus, and that's going to be 12a plus c plus d times x. All right, so 12a plus c plus d times x. That's good. And then we've just got our constant terms. So our constant terms are 8a, 4b, 2c, and d. Okay. So that's going to be plus, and I'm going to come down here and write it because I don't have enough room. So plus 8a minus 4b minus 2c minus d. Okay, so that was the only stupid mistake I had, was I wrote minus 3x squared instead of plus 3x squared. Not bad considering all this junk. All right, so there you have it. All right, so now we can solve. Now remember, we've already got a and d. We already know what a and d are. All right, so this tells me that a plus b is equal to 3. Okay, hang on a second. I'm going to explain where all this is coming from. 6a plus 3b plus c is equal to 15. You might already know, but I will explain it. 12a plus c plus d is equal to 21. And I have 8a minus 4b minus 2c minus d is equal to 15. All right. So keep in mind, all of this has to be equal. This side has to be equal to this side. Now look at this. You see the x cubed and the x cubed? Well, that has to equal 3 in order for them to be equal. And then you see the x squared and the x squared? Well, that number in front of the x squared over here has to be 15. And then the same thing here for the x. This has to equal 21. And then this constant term right here has to equal to 15. And that's where that comes from. All right, so now look at this. A is 2, D is negative 3. So A is 2, D is negative 3. And so, look, well, I've got 2 plus B equals 3, so B equals 1. And look, I've got A and B, so I can plug in 6 times 2 plus 3 times 1 plus C equals 15. So that is going to give me, let's see, that's 12 and 3 is 15. 15 minus 15, C is equal to 0. And so I've got, well, I already got A, C, and D, so that's good. Let's see, which one don't I have? Let's see, I've got A, D, B, A, B, C, and D. And is that all of them? Yep, so that's all of them. So I really didn't even need to use that last one over there. So I've got B is 1, C is 0, so we're good. So now I can plug all that into here, okay? And so let's see, how do I want to do that? Okay, so hopefully you got all that. I'm going to erase all this and work the problem up here. All right, so this is going to be the integral. Well, let's see, a is 2, so that's going to be 2 times 1 over x minus 1 dx plus, and b is 1, so that's going to be the integral of 1 over x plus 2 dx. C is what? 0, so that term is just going to go out. And then d is negative 3, so that's going to be minus the integral minus 3 times the integral 1 over x plus 2 cubed dx. All right, so this is equal to 2 natural log absolute value x minus 1 plus natural log absolute value x plus 2 minus, maybe a minus. Now this, I'll go ahead and show it. It's going to be done just like this one, except it's a cube down here. Okay, but we'll work it. So if we've got the integral of 1 over x plus 2 cubed dx, let u equal x plus. All right, so it stopped recording again, so I'm picking right up where it left off. What's happening is my screen's detaching. I don't know why. All right, so we're working on this. So we've got u equal x plus 2, then du is equal to dx. And so now we've got the integral of du over u cubed, which is equal to the integral u to the negative 3 du. So we add 1 to the exponent, that's negative 2, multiplied by the reciprocal of your new exponent plus c. And so this is going to be negative 1 over 2u squared, which is equal to negative 1 over 2 times x plus 2 squared. And so the negative and the negative, that makes a positive, and we do have a 3 right here. And so that's going to be 3 over 2 times x plus 2 squared plus c. Okay. And that's your answer. This is your answer right here. All right. So now let's go to the next problem. All right. So here we've got the integral of x over x minus 2 cubed, okay, dx. So this is a repeated factor, right? And the first thing you might do is, oh, well, let's set it up. The a over x minus 2 plus b over x minus 2 squared plus c over x minus 2 cubed. All right. Well, you could probably do that, but why? Okay, so let's look at this one. So this one, look, I'm just going to do u equals x minus 2, du is dx. I'm going to see if I can just use basic u substitution. Okay, just because you are learning partial fractions, integrating using partial fraction decomposition, doesn't mean you have to use it every time you see a fraction. Okay, so look at this. I'm going to let u equal x minus 2, du is equal to dx. All right, so I'm going to replace the x minus 2 with u, but I have a problem here. I've got an x. Well, what's x? Well, I want to get everything in terms of u, right? So what's x? Well, x is equal to u plus 2. So plug everything in. So this is going to be the integral u plus 2 over u squared. No, I'm sorry, not u squared. How about u cubed? And that's du. So the x got replaced with u plus 2, the x minus 2 got replaced with u, and the dx got replaced with du. And so now we've got the integral of 1 over u squared, right? U over u cubed is u squared plus 2 over u cubed dx. And so now this is going to be the integral u to the negative 2 plus 2u to the negative 3 du. So that's going to be u to the negative 1, add 1, multiply by the reciprocal of your new exponent, plus 2 times, that's u to the negative 2, right? Add 1, multiply by the reciprocal of your new exponent plus c. And so that's going to be negative 1 over u plus, and these 2's will cancel. And it's not going to be plus, it's going to be a minus 1 over u squared. Okay? And plus c. And so this is negative 1 over x minus 2 minus 1 over x minus 2 cubed plus, not cubed, squared. All right, and there's your answer. So hopefully you can see there, you know, just because you have the partial fractions doesn't mean you have to do partial fractions. Okay, try to see if you can just do a basic u substitution first, and then if you can't, then do partial fractions. All right, we've got non-repeated quadratic factors. So corresponding to each irreducible quadratic factor, ax squared plus bx plus c, that occurs once in the denominator, there is a partial fraction of the form. So this is how we write it. Ax plus b over the quadratic factor, where a and b are constants that we have to figure out what they are. Okay, so it's similar to it's going to be work just like we've been doing all these other ones. The only thing is, instead of writing a over b over, it's this over the quadratic factor. Okay, all right, so let's look at this. So first thing we want to do is we want to take the denominator and we want to factor it. Okay, and that's about as much as we can, well, that is as much as we can factor it. So now we've got 4x plus 4 over x times x squared plus 4 equals, so that's a over x. Okay, that we got a linear factor in here too, and plus, now here's our quadratic factor, so that's going to be bx plus c over x squared plus 4. All right. All right, so let's see what we've got. Well, just like before, we're going to multiply everything through by the common denominator. All right, so that's going to be 4x plus 4 equals a times x squared plus 4 plus bx plus c times x. All right, so let's look at this. So we could come over and we can say let x equal 0. Okay, and you know that's going to give us, if we do that, that's going to give us a equals 1, and that's fine, we can do that. But then we're not going to be able to find b and c, so we're going to be left with like what we had up here, this mess we had up here. Well, thankfully this one's not going to be as nasty. So, you know, I could do let x equal 0, solve for a. Okay, that's, you know, we can do that. But instead of doing that, let's just multiply it out, because we're going to have to multiply it out anyway. Okay, and you know, if it's still going to benefit us to let x equal 0, we'll go back and do that. Okay, but let's just see what happens here. So that's ax squared plus 4a plus bx squared plus cx. Okay, and so now I've got 4x plus 4 equals, and that's going to be a plus b times x squared. See, got common factors, common terms, x squared plus cx plus 4a. And see here, look at this, a plus b we know has to equal 0. There's no x squared term. C has to equal 4, and 4a is equal to 4, so a is equal to 1. See, I mean, we could have let the x equal 0, and we would have gotten 1, but, you know, it was no big deal to just multiply it out and do this. So now that's going to give us 1 plus b equals 0, so b is equal to -1. Okay? All right. Now, let's substitute all this in. So a is 1. So that's going to be the integral of 1 over x dx plus the integral. Now b is -1, c is 4. So that's negative x plus 4 over x squared plus 4 dx. So what I'm going to do here is I'm going to split this up. So that's going to be the integral 1 over x dx minus the integral x over x squared plus 4 plus 4 times the integral of 1 over x squared plus 4 dx. Okay, so I plugged everything in. Now, this is what? The natural log of absolute value of x minus, now what is this one? Well, what's the derivative of x squared plus 4? Derivative of x squared plus 4 is 2x. Oh, I forgot my dx here. Derivative of x squared plus 4 is 2x. Well, I'm missing a 2. So remember, we can multiply by 2, but then we have to come out here and multiply by a half. So when I do that, now I have the derivative of the denominator is in the numerator. So that's going to give me 1/2 natural log absolute value x squared plus 4 plus 4 times. Now, here we go. What is that antiderivative of this? Well, if you remember, there is a formula, and it says that 1 over a squared plus u squared du is equal to 1 over a times inverse tan of u over a plus c. All right. So you can see in this problem, a is 2. See, this is a squared. A squared is 4, so a is 2. So that equals 1 over 2, okay, which 4 times a half, that's 2, okay, so that's 2. And then that's going to be what? Inverse tangent of x over 2 plus c. Okay, there's your answer. So remember, the 2 I got from 4 times a half. Okay, it was 4 times 1/2. A is 2. All right. And that's your answer on that one. So you can see that one wasn't too bad. Okay. I left a bunch of room on that one. All right, so here let's look at this one. We've got another one. We're almost done. I think we've got this one and one more. So if you've been watching, don't leave. Just stay around for these. All right, so let's look at this. We got an x squared. We got an x squared plus 2x plus 2. This thing right here doesn't factor. So let's just see what happens. And we have x cubed plus 3x squared plus 2x plus 4 over x squared times x squared plus 2x plus 2 equals. Now this is, think of x squared as x, think of it as x minus 0 squared, which is x minus 0 times x minus 0. So it'd be kind of like two linear factors, so x times x. So that's a over x plus b over x squared plus, all right, now I've got this. That's a quadratic factor. So that's going to be cx plus d over x squared plus 2x plus 2. All right, and then we're going to multiply everything through by the common denominator, 2x plus 2. And so that's going to give me x cubed plus 3x squared plus 2x plus 4 equals ax times x squared plus 2x plus 2 plus b times x squared plus 2x plus 2 plus cx plus d times x squared. All right, so this one's going to be a nasty. It may not be too nasty. We'll see. But we gotta multiply all this out. So we've got x cubed plus 3x squared plus 2x plus 4 equals, so I'm going to distribute the ax. So that's ax cubed plus 2ax squared plus 2ax plus bx squared plus 2bx plus 2b plus cx cubed plus dx squared. So x cubed plus 3x squared plus 2x plus 4 equals. All right, so let's see. Let me put my check marks up above the common terms. I only got 2x cubes. So that's a plus c times x cubed. And then we'll erase those. Come on, there we go. Now let's look at the x squared. So that's here, here, and here, it looks like. So that's going to be plus 2a plus b plus d x squared. I'm going to check myself along the way. Just make sure no stupid mistakes. All right, now we're looking for the x terms. So that's going to be here, here, and that's it. So plus, that's going to be 2a plus 2b times x. And then I've got my constant term. And it looks like that is just 2b plus 2b. All right. So now we've got a plus c equals 1. See, the x cubed, the coefficient of x cubed is 1. And then I've got 2a plus b plus d. It has to equal 3. And then I have 2a plus 2b. That has to equal 2. And then I have 2b has to equal 4. And so here, b is equal to 2. All right, so plug the b into here. That's going to be 2a plus 2 times 2 equals 2. So that's 4. Negative 2, I believe a should be negative 1. Just solving that in my head, yeah. And so now we can plug the negative 1 into here. Negative 1 plus c equals 1, so c should equal 2. And then here I've got 2 times negative 1 plus 2 plus d equals 3. So that's just d equals 3 because that goes to 0. All right, so we're good. Now let's plug everything into here. So this is going to be a is negative 1, so that's negative 1 over x dx plus 2 times, and that's, well, yeah, 2 times 1 over x squared dx. See? Plug the 2 in. And then c and d. C is 2, d is 3, so plus the integral of 2x plus 3. Is that right? 2x plus 3? Yeah, d is 3, so 2x plus 3. And that should be over x squared plus 2x plus 2 dx. All right, so here we're going to have negative natural log x plus, and then when we integrate this, you'll write this as the integral x to the negative 2 dx, and then use the power rule. And that's basically going to give you it's going to basically, well, not basically, it is going to give you negative 2 over x. Okay, that's this one. Just do the power rule on that. Plus, okay, so here we go. What about this one? Well, this, I mean, what can we do? The derivative of the denominator is not in the numerator. But let's see, what is the derivative of the denominator? It's 2x plus 2, right? Man, I almost have it. If that 3 was a 2, that would work out good. But what if I did this? What if I wrote 2x plus 2 plus 1 over x squared plus 2x plus 2 dx, right? 2 plus 1, that's the same thing as 3. I just wrote it a little different. And so that's negative natural log absolute value of x minus 2 over x. And then that's going to be plus the integral 2x plus 2 over x squared plus 2x plus 2 dx plus the integral 1 over x squared plus 2x plus 2 dx. So I just split this up. Okay. And so now let's look at this. What is the what's the derivative of this denominator here? It's 2x plus 2. That's in the numerator. So that's negative natural log absolute value of x minus 2 over x plus natural log of x squared plus 2x plus 2 plus, all right, so now we got to do this last one here. What in the world is that? Well, let's do some rewriting. Boy, this one's fun, isn't it? So that's going to be 1 over, couldn't we write this as 2x plus 1 dx? Just split that 2 up. And so that's negative natural log absolute value of x minus 2 over x plus natural log x squared plus 2x plus 2 plus the integral 1 over, oh, look at there, that's x plus 1 squared plus 1 dx. So what is that? Well, what's a? A is 1. Okay, so that's negative natural log x minus 2 over x plus natural log absolute value x squared plus 2x plus 2 plus, and then this is just what? Well, a is 1. See this 1 right here? I mean, our a squared is 1. A is 1. So that's what? Inverse tan of what? X plus 1 plus c. And this is your answer. See, normally you have x squared. Well, this time we got an x plus 1. So it's the x plus 1 instead of x. This is inverse tangent. All right. One more problem and we will be done. Corresponding, well, this is repeated quadratic factors. It's going to be like what we did earlier. So corresponding to each irreducible quadratic factor, ax squared plus bx plus c, that occurs n times, is the denominator. In the denominator, there will be n partial fractions. And you can see it's similar to what we did with the linear ones. We just write it however many times we need, and then we got to solve for the a's and the b's. All right, so let's look at this one. All right. So the book I'm teaching out of did not have an example for this, but I went and I found one in the homework exercise, so I just pulled that one out. All right, so we've got 2x cubed over x squared plus 1 squared. So we've got a repeated quadratic factor. So that's going to be ax plus b over x squared plus 1 plus cx plus d over x squared plus 1 squared. All right. So now, once again, we just multiply by the common denominator, which is that. So that's 2x cubed equals ax plus b times x squared plus 1 plus, and then that's just going to be cx plus d. So I'll need to FOIL this out because, I mean, there's nothing I can let x equal to be 0. Well, I can let x equal 0, but see, I'm still going to have a, b, and d. You know, I won't be able to solve for anything. So let's multiply this out. 2x cubed equals ax cubed plus ax plus bx squared plus b plus cx plus d. All right, so that's going to be 2x cubed equals, that's going to be ax cubed and then plus bx squared plus, and that's going to be a plus c times x, and then plus B plus D. And so I get A is equal to 2. Oh, look at that. B is 0. A plus C is 0 because I have no x. I have no x squared term. And B plus D has to equal 0. And so if I plug the 2 in, 2 plus C equals 0. C equals negative 2. And then if B is 0, then that gives me D is 0. All right, so we're going to plug everything in. A is 2, B is 0. So that's going to give me 2x over x squared plus 1 dx. Okay. And then C is negative 2, so that's minus the integral. And let's see, C is negative 2, so negative 2 into there. D is 0, so that's minus the 2x, x squared plus 1 squared dx. So notice here, I didn't pull the 2 out. Normally I do, but what's the derivative of this? What's the derivative of x squared? 2x. So there you go, natural log x squared plus 1, and maybe minus here. But look at this. This I'm gonna need to use U substitution, right? So once again, well, I'll come over here and show you the work. Might as well. Video's been long enough, hasn't it? U equals x squared plus 1. Du is 2x dx. So there you go. 1 over u squared du. So that's u to the negative 2 du. So that's u to the negative 1 multiplied by the reciprocal of your new exponent plus c. So that's negative 1 over u, which is negative 1 over x squared plus 1. So that's, let me change colors. So minus 1 over x squared plus 1 plus c. All right, so that one worked out. So there's you a good sample, a bunch of examples. And the book I'm teaching out of for the applied calculus class, this video is actually broken up into 2 sections. I don't even know if anybody's hearing me talk right now. Most of you probably just left, but hopefully you didn't. But this is 2 sections combined into one. Okay, the first section this is on, it's the non-repeating linear factors, and then the next section is where you get into the repeating linear factors, the non-repeating quadratic and the repeating quadratic. Okay, so I just combined them into one video because it's the same thing. All right, so I hope this video helped. Check out my other videos. Give me a like, share, subscribe, comment. Thanks for watching, and I will see y'all in the next one. Later.